All right, so today we're going to go over weathering, and we have a lab. So there's not going to be an activity, it's just going to be the notes in the lab. Okay, so you have a copy of the notes. I would suggest either writing them out or typing them in. So weathering. There are two types of weathering. You've got chemical and physical. So physical weathering is mechanical breakdown of rocks. Remember how we had mechanical weathering? Mechanical and physical are interchangeable. So it's the breakdown of rocks caused by things like weather and changes in temperature and moving water. And one of the simplest forms of physical weathering is where the rock gets heated and cooled, which makes cracks. So you're seeing a crack form to start right here. A crack is formed, and then the precipitation comes and water gets in those cracks. And then when it gets cold enough, it freezes, expands, and further breaks the rock apart. This is called frost action. Another example of physical weathering is abrasion. This is where rocks are rubbing against rocks, which cause them to be round and smooth. This happens frequently in streams, rivers, and when waves are present in large lakes or oceans. So you can see I've got this picture, and this is from Rudy's. It's in Oswego. It's a really popular place in Oswego where you can pick up rocks and you can skip along, and you go right down by the water's edge and just throw some rocks in. And they're pretty much all rounded. So for this type for physical weathering to occur, you need the temperature to go above and below freezing. Therefore, there has to be a lot of moisture in the air or atmosphere. Chemical weathering. So this is the erosion or disintegration of rocks caused by a chemical process. One of the best chemical processes in nature, in Mother Nature, is carbonic acid. This is the combination of just carbon dioxide and water. That is made through combustion, burning. So anytime burnings happen, you have a combination of carbon dioxide and water being formed. And so remember back to Unit 2, what we just did, that the mineral calcite is susceptible to acids. That's the only one that bubbles with acids. If you don't remember, look at page 16. It does say it in the comments. And the metamorphic rock marble has calcite in it. So what's one thing that has calcite in it? Well, look at this right here. It is a gravestone, and look, you can barely see the lettering on there. That's a marble gravestone. The older ones in cemeteries are affected by that carbonic acid or sulfuric acid, and this is from the acid rain, which derives from burning of coal, which is why burning of coal is not the best way to produce energy, because it causes all this acid rain and it acidifies the environment, which causes lots and lots of problems. So you saw that it dissolved the numbers and letters on these marble tombstones, these gravestones, so you can't read them anymore. Calcite is also in the sedimentary rock limestone, which when carbonic acid interacts with it, remember this is pushed down and smushed down, so it's deep within the earth. When the water, the acid rain seeps through, it forms, pardon me, these huge caves. And so chemical weathering happens best. So remember, physical happens when you go above and below and there's moisture in the air. Now, chemical, this happens best when temperature is hot and there's a lot of moisture in the atmosphere. All right. So this last one, let me move me. This last thing that we see, the amount of surface area determines how fast the rocks weather. What do I mean by that? Well, the greater the surface area, the faster it weathers. So looking at this is one cube. It's like a 2 by 2 by 2 by 2. That's the square, the surface area. So it's 2 by 2 by 2 by 2. Now we've broken up that square and we've broken it up into littler squares. So now they're 1 by 1, and you got a lot of 1 by 1. So these are going to dissolve faster than this. And then if I break them up even more into 0.5 by 0.5, they're even smaller than this one. So I know this concept is a little bit difficult to understand, but think of it like this. Have you ever had sugar cubes, like the cubes of sugar, and you plop them in your beverage of choice? It dissolves slower than if you were to pour in granules, like granulated sugar. So if you pour those in, they tend to dissolve a lot faster. It takes a lot less time because there's more surface area on that tiny little bit than that huge chunk. Because think, all this outside stuff has to dissolve first before the stuff on the inside can dissolve. Now the stuff on the inside right here is already shown because it's broken apart and it's split into tiny little pieces. So it's got, the water has more access to break down the bits and pieces. Okay, so rather quick notes today. Make sure you do the lab after this. I will leave instructions in the lab how to do it. If you have any questions, please get a hold of me, email me, class tag, or Zoom. Zoom meetings once a week, 9:30 to 10, 1 to 2. Come see me more than that, especially if you have questions. I hope you guys have a great day.